9072. Where is the critical altitude of a supercharged reciprocating engine? A. The highest altitude at which a desired manifold pressure can be obtained. B. Highest altitude where the mixture can be leaned to best power ratio. C. The altitude at which maximum allowable BMEP can be obtained. The correct answer is A. The highest altitude at which a desired manifold pressure can be obtained. The critical altitude of a supercharged reciprocating engine refers to the maximum altitude at which the engine can maintain a desired manifold pressure. Manifold pressure is the measure of air pressure in the intake manifold of the engine and is directly related to the engine's performance and power output. As an aircraft ascends to higher altitudes, the air density decreases, resulting in reduced manifold pressure. The supercharger's role is to compensate for this decrease in air density by compressing the incoming air, thereby maintaining the desired manifold pressure. However, there is a limit to the supercharger's effectiveness, and at a certain altitude, called the critical altitude, it can no longer provide the desired manifold pressure. At the critical altitude, the engine's power output starts to decrease due to inadequate air density and reduced manifold pressure. Pilots must be aware of the critical altitude to ensure optimal engine performance and power settings during flight. 9073. What is controlled by the wastegate of a turbocharged reciprocating engine? A. Supercharger gear ratio. B. Exhaust gas discharge. C. Throttle opening. The correct answer is B. The wastegate of a turbocharged reciprocating engine is responsible for controlling the exhaust gas discharge from the turbine side of the turbocharger. The turbocharger consists of two main components, the turbine and the compressor. The turbine is driven by the engine's exhaust gases, and its primary function is to drive the compressor, which compresses the incoming air and delivers it to the engine for improved performance. The wastegate is a valve located in the exhaust system of the engine, upstream of the turbine. Its purpose is to regulate the flow of exhaust gases that drive the turbine. By controlling the wastegate, the engine's boost pressure, the pressure of the compressed air delivered to the engine, can be regulated. When the wastegate is fully closed, all of the exhaust gases flow through the turbine, providing maximum boost pressure to the engine. On the other hand, when the wastegate is partially open or fully open, it diverts a portion of the exhaust gases away from the turbine, reducing the speed of the turbine and, consequently, the boost pressure. This allows the engine to maintain a desired level of boost pressure and prevent overboosting, which could lead to engine damage. Therefore, the wastegate controls the exhaust gas discharge and, subsequently, the boost pressure of a turbocharged reciprocating engine. 9068. Under normal operating conditions, which combination of MAP and RPM produce the most severe wear, fatigue, and damage to high-performance reciprocating engines? A. High RPM and low MAP. B. Low RPM and high MAP. C. High RPM and high MAP. The correct answer is C. At high RPM and low MAP, the rate of wear and fatigue damage is the greatest. 9068-1. How are turbine engines classified? A. The type of compressor or combination of compressors they use. B. The method in which the air/fuel mixture is ignited. C. The flow of air through the engine and how power is produced. The correct answer is A. The types of compressors used by different types of turbine engines include centrifugal-flow, axial-flow, and centrifugal-axial-flow. 9058. Which place in the turbojet engine is subjected to the highest temperature? A. Compressor discharge. B. Fuel spray nozzles. C. Turbine inlet. The correct answer is C. Turbine inlet. In a turbojet engine, the highest temperature is typically encountered at the turbine inlet. The turbine inlet refers to the location where the hot gases from the combustion chamber enter the turbine section of the engine. After the air is compressed in the compressor section and mixed with fuel in the combustion chamber, it undergoes combustion, resulting in a high-temperature and high-pressure gas mixture. This hot gas is then directed into the turbine section, where it expands and imparts energy to drive the turbine blades. The turbine section is designed to extract energy from the hot gas flow to drive the compressor and any other necessary accessories, such as generators or pumps. As the hot gas passes over the turbine blades, it transfers a significant amount of heat and energy to them. Due to the high-temperature nature of the gas flow and the heat transfer occurring between the gas and the turbine blades, the turbine inlet experiences the highest temperature within the turbojet engine. The turbine blades are specifically designed to withstand these high temperatures through the use of advanced materials and cooling techniques. Therefore, option C, turbine inlet, is the correct answer for the location in a turbojet engine that is subjected to the highest temperature.